Salam and welcome to my channel. So in this particular video, we're going to be working on the question on the screen that says, by how much does the chemical potential of benzene change when the pressure exerted on a sample is increased from 100 kilopascals to 10 megapascals? Take the mass density of benzene to be 0.8765 gram per centimeter cube. So the first thing you have to note is this: we're going to reread the question and we're just going to make note of key information. They said, by how much does the chemical potential of benzene change? So basically, what they're actually asking us to solve for is a change in chemical potential when the pressure exerted on a sample is increased. So if there's an increase, that means there's going to be two different pressures from 100 kilopascal to 10 megapascal. So we know, of course, there's an increase, meaning there is initial pressure and final pressure, where the final pressure is greater than the initial pressure. So, anyways, initial pressure is 100 kilopascal, and then the final pressure is 10 megapascal. We're also told to take the mass density of benzene to be 0.8765 gram per centimeter cube. So the mass density is going to be 0.8765 gram per centimeter cube. Now, one thing I quickly need to mention is that because of we're getting our question in form of kilo, mega, it's going to be a little bit confusing when we start doing solution. So the best thing is for us to actually write it fully. So P initial 100 kilopascal is just 100 times 10 to the power of 3 pascals. So that's going to be 100,000 pascals. Okay. And then 10 megapascal is just going to be 10 times 10 to the power of 6 pascals. So that's going to be 10 with 6 zeros added. So that is 10 million pascals, the same thing as 10 megapascals. I just wanted to put that on. Now, you're going to be wondering, okay, how do we solve a question where we're asked to solve the change in chemical potential? And in this question, we see that we have a change in pressure. So anytime you're asked to solve for the change in chemical potential, when there is a change in pressure, what formula you're going to be using is going to be the change in chemical potential is equal to change in pressure times molar volume. So you're going to actually use this formula to solve this question. So looking at this, we know that in order for us to solve what we're asking for, we're actually supposed to determine what the change in pressure is as well as what the molar volume is. From our knowledge of chemistry, science, everything we know change is just going to be final minus initial. So change in pressure, okay, same thing as P final minus P initial. So change in pressure is going to be 10 million pascals minus 100,000 pascal. So 10 million minus 100,000, the change in pressure ends up becoming 9,900,000 pascal. So yeah, that is it. That is what's going to happen. So that's basically what's going to happen. We've already solved for this. Now the next thing we have to solve for is the molar volume. But before we go ahead and we do that, let's not forget Pascal is just basically Newton per meter square. So we can actually have our change in pressure to also be 9,900,000 Newton per meter squared. Okay, so that's basically it. Anyways, the molar volume is volume divided by number of moles. So that is basically what molar volume is. Volume divided by number of moles. So yeah, that's basically what it is. Volume divided by number of moles. Now you're going to be wondering, okay, in order for me to get a molar volume, we're not giving the molar volume, we're not giving the volume, neither were we giving number of moles. So how am I going to solve this question? Well, it's not going to be hard because we have to remember the other parameters information we're given in the question. We were given the value of mass density, which is 0.8765 gram per centimeter cube. Now, we can use our information or knowledge of density to actually determine the molar volume. Let's not forget, in our sciences, when we were much younger, we learned that density is equal to mass over volume. And here, we're not just asked to solve for volume, we're asked to solve for molar volume. So to go from volume to molar volume, we just divide this denominator by number of moles, and we're also going to divide the numerator by number of moles. So we have to do whatever we do in the denominator to the numerator. So Mass divided by number of moles, yes, chemistry is simply molar mass. Let's not forget that. Mass divided by number of moles is simply molar mass, and volume divided by number of moles is molar volume. So actually, density can also be rewritten as molar volume divided by, sorry, density can also be written as molar mass divided by molar volume. So from this information, we can actually rewrite what the molar volume will be. So molar volume becomes molar mass divided by density. So this is what we're actually going to use to get our answer for molar volume. So molar volume, we have molar mass and we have density. We already know what our density is, right? What did we say our density was again? Our density was or is 0.8765 gram per cm cube, right? And we know our molar volume, sorry, we know our molar mass to be what? Well, we don't actually know what the molar mass is because we're not given. But if you go back to the question, you remember that we're given the identity of the sample that we're dealing with, right? We're giving that sample to be benzene. And we know that benzene has a unique molar mass, meaning when you calculate the molar mass of C6H6, which is the molar mass of benzene, you are going to end up with 78.11 gram per mole. We're already at a higher level of chemistry. I don't need to actually go through the process of saying 12.06 times 6 plus 1.00 times 6. I don't have to do that. You guys have passed that. But just remember that benzene is C6H6. The molar mass of that is, you can go ahead and calculate down your own time. But anyways, the molar mass of that is actually 78.11 gram per mole. So we can just simply cancel out the grams, input this information in a calculator. We end up with molar volume is equal to 89.1158 1 over mole. Let's not forget this is now 1 over mole since we've decided the gram divided by 1 over centimeter cube. And I'm sure you guys are wondering, why is she going through so much detail? We know better. I'm going through so much detail because sometimes when you're actually very confident with what you're doing, you may actually start to ignore the important parts. So 1 over mole divided by 1 over centimeter cube is the same thing as 1 over mole times centimeter cube over 1, which is the same thing as centimeter cube per mole. Don't forget we're solving for molar volume. So you're going to have the unit for volume divided by the unit for mole. So this is basically our work. So knowing this, we can now go ahead and substitute, right? We actually asked to find the chemical potential. So all the other processes we did was just to find the information we need in order to find the chemical potential. So the chemical potential, let's not forget, is simply the change in pressure times the molar volume. So chemical change in chemical potential, change in pressure is 9,900,000 Newton per meter squared times the molar volume, which is 89.1158 centimeter cube per mole. Now, even though our work looks good so far, we've run into a problem. We see now that the meter squared, right? The meter squared is in meter and the centimeter cube is in centimeter. So we cannot cancel out two different units. So we have to either go from centimeter cube to meter cube or to meter cube to centimeter cube. So I am going to instead go from centimeter cube to meter cube. So I'm going to go from centimeter cube to meter cube. I'm going to do a quick unit conversion and then go back to our question. So when we want to go from 89.1158 centimeter cube per mole, okay, times, we're going to have the centimeter cube at the bottom and we're going to have the meter cube up top. When we do that, we end up with, here is just simply going to be 1 meter cube is the same thing as 1 times 10 to the power 6 centimeter cube, or 1 million centimeter cube. Of course, you're going to cancel out the centimeter cube here and the centimeter cube here. So it's just saying the new answer will be 89.1158 times 10 raised to the power of negative 6 meter cube per mole. So this is basically going to be the answer to this one. So we can now substitute this information back into our work. So the change in chemical potential is actually now going to be change in chemical potential 9,900,000 Newton per meter squared times 89.1158 times 10 to the power of -6 meter cube per mole. So now that we have our work in very similar things, right? Basically, we have our work similarly. We can now cancel out the units, right? Not the work, actually, the units in a similar. Well, now that we have the same units, basically, we can cancel out meters squared. We can cancel out the meter cube from it, and we still have meters left. So we have 9,900,000 Newton times 89.1158 times 10 to the power of -6 meters per mole. So that is it. So when we put this information in our calculator, we end up getting 882.246 Newton meter per mole. Now, this is our answer, but of course, we have to fine tune it a little bit. Let's not forget that Newton meter is the same thing as joules from our understanding of Newton and meter. Newton, formula for force, meter, formula for distance. First time distance is work done. Work done unit is also joules because it's also a form of energy. So we can rewrite the change in chemical potential to be 882.246 joule per mole. And again, we are chemists, so we have to try to make sure our work is clean and neat, right? For it to be very, very clean and neat, we have to put in the proper number of significant figures. And when we go back to the question, we see we have um, 3 sig figs for 100 kilopascal, 2 sig figs for 10 megapascals, and 4 sig figs here. We can just put our answer in 2 sig figs. Or sometimes your professor could say, put this in like 5 sig figs, 4 sig3. So for listen to the instruction for the question, if you're not given an instruction from the question, that's when you can actually use the significant figures. So doing that, making our work into 2 sig figs, I'm going to end up with 8.8 times 1, 2, 10 raised to the power of 2 joule per mole. So this is how I am going to leave my final answer because I'm strictly putting it in 2 sig figs. And of course, the scientific notation. So yeah, that is the end of this question. If you want to say 882 joule per mole, be my guest. I'll be 3 sig figs, whatever you want to do. If you want to say 882.2 joule per mole, that's 4 sig figs, whatever you want to do. Just make sure you clarify with your professor number of significant figures or decimal places, or you just do it this way. So if you have any questions, please make sure you put in the comment section. I'm a tutor who helps students succeed in all their STEM related courses, whether they're in middle school, high school, or college. So if you like my way of teaching and you would like to succeed in all your STEM related courses, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.